Questions 83 to 86 in the ACER green paper. Question 83. For the compounds 1, 2, 3 and 4, those that have chiral carbons are. So chiral carbons are carbons which are attached to 4 different groups. So let's go through each of these compounds and see whether any of them have a chiral carbon. Let's start with 1. Well, none of these ones are going to be chiral carbons because they're all attached to 2 hydrogens. But let's take a look at this one, this carbon here. Well, this carbon is attached to CH3OH and is also attached to this carbon and this carbon. Now they're obviously the same, so usually you go around the ring and you'll find that those 2 carbons are actually identical if you go around the ring. So in other words, one does not have a chiral carbon because while CH3 and OH are unique, these 2 carbons, the ring carbons, are actually identical. Diagram 2, on the other hand, has 2 chiral carbons. One of them is here and one of them is here. So this one is attached to CH3. There's a hydrogen just not drawn but implied, and it's also attached to this carbon here and this carbon here, which are different because this carbon is attached to an OH while this one is not. So 2 is definitely a chiral structure with a chiral carbon. 3, again, we have a similar situation, 2 chiral carbons, and pretty much for the same reason as before, because say this one is attached to CH3, H not drawn in but implied, and the carbon here is attached to an OH while carbon here is attached to 2 hydrogens. So 3 is again a chiral structure. Finally 4, well 4 has 1 chiral carbon and it's this one, and the reason is, so this one is attached again CH3 implied H, and it's also attached to this carbon and this carbon. So these 2 carbons are identical, but if you go one more around the circle, what you get is if you compare these 2 carbons, well they're different. This one is attached to the O, whilst this one is attached to 2 hydrogens. So they're actually a unique line here and a unique line of carbons here. So this carbon is a chiral center. So therefore, what we get is 2, 3, and 4 have chiral carbons, and therefore C is the correct answer for question 83. Question 84. So the most important thing to know for this question is that the higher the atomic number of the atom, the greater the priority. So let's go through a couple of these answers. In C, we have our first bond to carbon, and after that, the first bond in the other group is to bromine. So bromine has a higher atomic number than carbon, so therefore it should have a higher priority, but that's not true in C, so we can rule out C. D, well, we have our first bond to carbon and our first bond to nitrogen. So nitrogen has a higher atomic number than carbon, so therefore nitrogen should have the higher priority, but that's not what's being shown in D, so D is incorrect. And B, we have our first bond to oxygen, and in the other group, our first bond is to carbon. Now oxygen has a higher atomic number than carbon, so therefore what's being shown in B is correct, that oxygen has a higher priority than carbon, so B is correct. So for question 85, we're asked to figure out whether structures 1 and 2 are superimposable on each other. And there's a really specific rule that relates to Fisher projections, and it's that you're allowed to switch 2 groups simultaneously. So if we switch this group and this group, we also have to switch the positions of this group and this group. So if we do that, well, we'll see that this right hand corner will be identical between 1 and 2. So CH2, CH3 will go from the right position to that up position, and H will go to the right position. And that mimics what we've got in 2. And similarly, CH3 will now be at the bottom and OH will now be on the left. So these two structures are superimposable on each other. So A is the correct answer. Question 86. Consider the Fisher projections of the following 3 compounds, 1, 2, and 3. The S configuration is found in. So the S configuration is found if when you go from the highest to the lowest priority groupings, you find yourself going in a counterclockwise direction. So let's try and answer question 86. For structure 1, we have the following 4 groupings, and the priorities are listed as such. So the highest priority is bromine with number 1. Second highest is that carboxylic, then the alkyl group, then the hydrogen. So the lowest priority one, you generally want it to be facing away from you. So one way to do that is to, like before in question 85, is to move all of these groupings. So if we move hydrogen, say, to the top position, well, we also need to simultaneously move these ones. So what you get is this. I'm just going to list the priorities versus just listing the grouping, because that's all we need to know. We just need to know what the priorities are. So we get this, and if we go from our highest priority to our lowest priority, well, we see that we're going in a counterclockwise direction, and that is therefore an S configuration. Alright, so let's try this again for structure 2. So we have hydrogen is lowest priority, highest priority, second highest, third highest. So our lowest priority one is already facing away from us with the hydrogen. So we can just sort of go from here. What we've got, 1, 2, 3, so we're going in this direction. Again, that is counterclockwise. So therefore structure 2 is also S configuration. And finally, we have this. Well, let's list our priorities. So again, luckily we've already got our hydrogen facing away from us, and when we go from priority 1 to priority 3, we're going in a clockwise direction. So this is a R config. So overall, structures 1 and 2 are S configuration, so therefore D is the correct answer for question 86. If you're confused as to why the hydrogen in this position is facing away from you, I'd have a quick look at what the Fisher structures represent. But basically, the horizontal, the groupings along the horizontal plane are coming out of the page, and the groupings along the vertical plane are going into the page.